So in this video, we're going to continue solving problems from exercise 7.1 and this is our problem number 4. So let's read what the problem says. Let me try to zoom in. Okay. So L and M are two parallel lines intersected by another pair of parallel lines P and Q. So let me use the highlighter here. L and M are two parallel lines, okay, and they're intersected by another pair of parallel lines which are P and Q. So P and Q are parallel to each other and L and M are also parallel to each other. Two parallel lines are crossing each other and we have to show that triangle ABC is congruent to triangle CDA. So whenever they have already mentioned the triangles which we have to prove congruent to each other, it's quite straightforward. We have to just notice the order in which the alphabets are mentioned and thus we can prove it. So I'm just rewriting it, triangle ABC. So I'll say to prove, okay, triangle ABC is congruent to triangle CDA. Okay, so as we all know that in parallel lines, sorry, so this is a parallel line and these are also the parallel lines. AC is an intercept. AC is an intercept to the parallel lines. So we know by the parallel lines concept that this angle is equal to this angle. Okay, why? Because this is a parallel line and this is intercept, so this angle is equal to this angle. Okay, similarly we have uh, what other angle? Yes, similarly we have this angle as equal to this angle. Okay, why? Because these are the two parallel lines and this is the intercept. Let me do one thing. Let me try to show it in a separate way. So if these are the two parallel lines which are P and Q, okay, and this is my intercept AC, this is my intercept AC, okay, then I can say this angle is equal to this angle. Okay, so this angle is equal to this angle. Similarly, so this is considering the parallel lines P and Q. If I consider parallel lines L and M, so this is my parallel line L, this is my parallel line M, and once again this is the intercept. So in this case, this is equal to this. So this is the intercept that I have to consider. So here the confusion might be because we have all the four parallel lines at one place and there is one common intercept. So it's a bit difficult to visualize that whether it is this Z or whether it is this Z or what. So I've drawn it separately so that we can understand. Now, in these two triangles, we have two pair of angles equal to each other, and then of course this side AC is common to both of them. So by angle side, the triangles will be congruent to each other. That's how we proceed. Let me erase this. Okay, I want to erase everything. Yes. Now the thing that we have to be a bit careful about is the order in which the alphabets are mentioned. So we'll follow them very strictly. In order to prove these two triangles are equal to each other, the first step is angle. So this angle A, which is is equal to angle C. Okay, this angle C and this angle A. So angle A is actually equal to angle C. Now that angle A, let us write it in the form of BAC. Angle BAC is actually equal to angle. So since we went like this, BAC will follow the same order 1, 2, 3, which is DCA. Okay, the order is very important, 1-to-1 correspondence of the triangles. Okay, next, then, okay, let me just erase this. Okay, let me take a small. Yeah, now, so BAC is done. So BAC is done. Now we have to focus on this green one, which is BCA. So again, I'm going to just write it down. Angle BCA. And how is BCA coming? BCA. So same here, 1, 2, 3 is equal to angle DAC. So that's what we said. Uh, B, what is it? BCA is equal to DAC. Okay, this green, these two angles. So both the angles are equal to each other. And finally, we have third point, which is about the common side. So the side, let me highlight the side. First, let's erase this. Yes. Now, which side is it? The common side is AC. So this side AC, and here it is CA. Doesn't matter. AC, CA is basically the same side, which is congruent to each other. So I'm going to say side AC is equal to side CA. Okay. And thus we can say, okay, from which congruence criteria are we going to use? From AAS congruence criteria, we can say that triangle ABC is congruent to triangle CDA. Quite simple and straightforward problem. The only thing a bit tricky in this problem was, since they are given four parallel lines in intersecting each other, we have to be a little bit careful in visualizing that which two parallel lines we consider while considering this intercept. At one time we have to consider LM, and at other time we have to consider PQ, and thus we have to find out the angles which are congruent to each other.